Hey, we're going to get started with our lesson today. It's going to be on 1.2, like I said, or it's titled. But I first want to start out because we haven't talked about this. What's going to be your final product? What is that final thing that you guys are going to be creating in this class? And that's what I want to start with here with this unit piece. And this came from 1.1. The reason why we're skipping 1.1 is it shows you how to use MIT App Inventor and how to import files or download files. We've already done that. So what we're going to do today is we're going to just do the unit problem and then jump into 1.2. So you're going to need a notebook with this or some paper to be able to write down your piece. And I'm going to be asking you to share with me your answer to 1.2. You can do it either on paper or electronically. You can use draw.io. You can use Google Drawing or whatever, but I'll talk about that when I get there later. First, this is our ultimate problem by the end. You can see all these people sitting around this family. It says a local computer technology organization is interested in creating an educational outreach program that teaches people how mobile apps can be used to solve real-life problems that are important to individuals, to their families, and to the communities. They need your help to create apps that they can use as examples. So they want you to use your creativity and design and create a mobile app that solves a problem that is important to you, your family, or your community. The app you and your classmates will create are going to be used by the organization to showcase the power of creating mobile apps to help solve problems. This is your final project. So you're going to be creating your own apps on your own at the end. So it says, keep in mind that technology can be very helpful to people and society if used safely and responsibly. So some of these questions are things to think about as we get later into the unit. We'll come back to this at the end as well. Keep in mind that technology can be helpful by asking these questions. How do you think you can use technology to help people? What are you passionate about? What interests you? What needs do you have that an app could help with? Can you think of friends or family members who might have the need for a new app to help them with their daily lives? And what are ways that you can give back to the community? So there's many ways that you can contribute to society. Some examples include health and wellness apps, community service apps, emergency preparedness apps, environmental science apps, education apps, and maybe school culture apps. There's endless possibilities of what you can do with this. So you're going to just start thinking about this now as we move forward. We'll come back to this whole problem throughout the quarter. Put that picture up there. It's cool. Okay, I'm going to scroll over to 1.2 now. I would encourage you, if you want, to open up, and then I'm just going to hide that so we got a big full screen, to open this up on your computer if you want as well, your PLTW, my.pltw.org, and then log in with your username and password. If not, just kind of follow along here so you can see what we're working with. Okay? So let's start with this picture here. You can see they're all working hard. What are they working on? Creating a list of how to stay up late. Go get home from school, rest up, nap until dinner, eat dinner. You need the energy. Inform mom and dad of a late night plan, and then stay up late. It's party time. And they go, I don't think that's going to work, Milo. Well, let's see. So think about your daily routine of brushing your teeth, getting dressed, or even getting to school. To accomplish these tasks, you have to complete a series of many small steps, which in computer science, a sequence of those many small steps or detailed instructions, we call that an algorithm. So since computers do not have a brain or the ability to think on their own, computer scientists have to create algorithms so that the brain knows what to think. So we're going to start out by watching this video, and then we will continue on with our stuff for today. I always like to put the captions on in case it's hard to read or hard to hear.
This video introduces you to algorithmic thinking. Before you create something, it's best to make a plan. Think about building this beautiful sandcastle. How would you create this elaborate structure? You would need to build the castle one part at a time, completing each part using carefully orchestrated steps. Believe it or not, this type of planning is an example of algorithmic thinking. Algorithmic thinking is the process of completing a task using a series of clearly defined steps. In computer science, algorithmic thinking is used to solve problems in computing. For example, think about all the features of a mobile app. Each one of those features requires careful thought, using clearly defined steps to create it. Even simple apps can have hundreds of steps to make them function correctly. Computer scientists work with customers or clients who will purchase the program, app, or device they design. Often the client is not familiar with the computer software used to create the product, so the computer scientist uses an algorithm to plan out the tasks required. An algorithm is a set of instructions used to carry out a task. Computer scientists write their algorithms using a simple natural language like English, so it's easier for their clients to understand. To computer scientists, creating algorithms is like when an architect creates a blueprint or when a doctor documents your medical history. Algorithms are used in many fields, such as science, engineering, arts, sports, and of course, math. Now there are several types of algorithms. For this video, we're going to explore linear algorithms. A linear algorithm has only one sequence of steps. So how do you write a linear algorithm? We'll use algorithmic thinking to work through an example together. First, we need to identify a task to complete. Let's write an algorithm to plan a birthday party for your best friend. Take a moment to think about what you need to do to plan a party. You'll need to purchase party decorations and put them up. So that means you'll have to clean up after the party. You'll need to decide where to host the party, send invitations to the guests, then throw the party and have fun. Oh, don't forget about the food. You'll have to purchase the food and birthday cake. And choose the date for the party. Wow, quite a few steps go into a birthday party, don't they? Now that we have the steps, let's put them in the correct order. How would you organize this algorithm so you can plan an awesome party for your friend? One way to organize an algorithm is to use a step-by-step list, similar to a recipe. Each step clearly details what is needed to complete the task and is in the correct order in the list. So let's put the birthday party planning steps in order. Step 1, choose the date to have the party. Step 2, decide where to host the party. Step 3, send invitations to the guests. Step 4, order the food and cake. Step 5, purchase the party decorations. Step 6, set up the food and decorations. Step 7, throw the party and have fun. And Step 8, clean up after the party. Now that the steps are organized, you can see how easy it would be for someone else to follow the directions and plan the party. This written list is just one way you can organize an algorithm. Another way is using a flowchart. A flowchart is a diagram that represents an algorithm using shapes and arrows. The arrows point to the next step in the process from start to finish. The flowchart is a great visual to understand linear algorithms. Notice that the sequence of steps for the party flow in a straight line. It's a linear flow. Similar to our party planning example, computer scientists create linear algorithms to instruct computers and devices to perform various tasks in a certain order. Now that you've learned about algorithmic thinking, you're ready to get started with creating your own algorithms.
All right. Let's close that up. So they talk about flowcharts, and I'm just going to show you now, and then you can go back and look at these later on your own time. It's a video. You can pause and rewind whenever you want. But I do have this video linked here on Google Classroom in case it was hard to watch. You can watch it again here if you want. I know you're not going to, but I'm going to show it to you anyways. Here are the notes for flowcharts that they were talking about. These are the pieces. So instead of making you take the notes, documents right here so you can see it. We're working with linear today, just linear flowcharts. Next time we do flowcharting, we'll be looking at conditional flowcharts. And because this is at-home learning or digital learning, distance learning, whatever it is, I know this is a little different than if we were right in the classroom. So I'm not worried too much about how specific and accurate you guys are with this just once you trying it out. Okay, so as we move on, we'll see that we learned in the video that linear algorithms have only one sequence of instructions, so it completes a task in order. That's a flowchart. Here's an example. It starts at the beginning oval, ends with the end oval. That's how things go. And in between are the directions or the expectations in order. So, step 1, create a volcano. Step 2, add beaker to the middle of the volcano. Step 3 is add baking soda to a beaker, adding vinegar to the beaker, and then clean up your spill. As you know, it's making a volcano. But that's how you set it up. Again, ovals to begin and end, rectangles are all the actions in between, and then the arrows connect them. So the ovals are the events, the rectangles are all the actions in between, and then the arrows just join things together. Here's one to look at. So you can see at the beginning, and the other thing I like about this one is you can see that it's flowing in a direction. The arrows are there to show you that. It doesn't have to be in a straight line. That's what I like about this picture is it shows you can have them go back and forth, zigzag. I'm going to do one with you guys on the on my notebook here, in my notebook in just a little bit. So what is the action going on here? Well, this is very fitting for what's going on right now because we always want to make sure that we are constantly washing our hands and making sure that we're being healthy. So this flow chart shows you that. Okay? So we have this hide and seek activity, which we're going to skip. Actually, what we're going to do is we're going to go over here to my wonderful notebook, and we're going to practice doing a flow chart. Okay? So what I want us to do is I want us to just do a simple flow chart together so you can see how it works. Okay, so I want you to think about what does it look like if you are brushing your teeth. Okay, so think about this as if it was brushing your teeth is the directions. So on your paper, you can follow along with me here and make your own copy. Let me get the light a little brighter here for us so you can see the paper better. Focus it up. Okay, so the first thing you have to do is you have to start out with the oval. Okay, and in the oval we write begin because that's the start of the activity. So we'll draw an arrow down and we're doing brushing our teeth. So what's the first thing you normally need to do when you're brushing your teeth? Probably get toothbrush and toothpaste. So those are both their own actions. So first one will be get toothbrush. Sorry, I'm a lefty and it's hard to read. Get toothbrush, then get toothpaste. Okay, get toothbrush, then get toothpaste. I wonder if I can zoom this in a little closer. There we go. So once you have them, then what do you do with them? Well, you're going to have to apply the toothpaste to the toothbrush. So put paste on brush. Put paste on brush. Okay? Then what happens after you put the paste on the brush? Well, then you're going to have to put the toothbrush to your teeth, right? So I'm going to draw an arrow this way so I can show you we don't have to use up the whole space. And we will say brush teeth with paste. Okay, brush teeth with paste. Oh, wow. Spelled with wrong. There we go. So after you apply the teeth with the paste, don't forget you're going to have to spit out paste. Okay. Then what do you normally do after this? Then you normally have to rinse mouth. Okay. Rinse mouth. And then what do you normally do after you've rinsed your mouth out? Then we're going to have to put paste away. Put away paste. Okay. And then after you put away the paste, put away toothbrush. And now that everything's been put away, the final thing we do is we have end. And that's what a flowchart looks like as you are kind of working through how to brush your teeth. Real simple, but if we were robots and we had to do everything in order, this is kind of how it would look like. Okay, so make sure you copy this down so you have an example with you of a flowchart before moving on. This is where you can pause the video and then come back. I'm glad you paused and came back. You can see I didn't leave you. All right. So now you're going to do another one, and this one's going to be a little longer, but this is your actual test for me to see how well you're going to do with this. I'm going to expect you to submit to me your document of your flowchart here. This could mean that you're going to send me a digital copy, or it could mean that you're going to just take a picture of what you did in your notebook and send me that. Either way, you're going to be submitting to me your flowchart for this. And as far as being able to do it digitally too, I can show you a tool that I have created that you guys can use to help you with. So we have a school bus here that is broken, or at least the GPS is broken. We have to get the students from the school parking lot to the museum parking lot. And what you need to do is you need to create an algorithm that shows step by step how to get up the road and follow one of these paths. This is usually the path people use to get to the museum. We're not going to be able to work with a partner, so you're going to have to work alone on this. But these are the only commands that you can use. Move forward, and that would mean that your bus can only move forward one block. So this is a block, this is a block, this is a block, and this is a block. Turning left and turning right are the other two commands. And turning left and turning right means you turn only in this box. Let me show you now with the thing that I have on Google Classroom. So you can use this to help build your flowchart if you want to. But let's say this is our bus, okay? And I'm going to put the bus there, and we're going to have it move forward. That would be the command move forward. Move forward. Move forward. You getting the hint here? Move forward. Now, if we want it to turn left, because left is the direction we need to turn, you can practice this by turning the bus to make sure it's always pointed forward. We had to turn left, okay, counterclockwise. I turned this left, and then we can move on. So you guys can use this little example thing I have here on Google Classroom to help you stay organized with your stuff, and then move the stuff back if you want to. You can do that. I think you just have to do file and make a copy. So let's look at this bus, and let's look at our flowchart. Let's at least start one together. So this is what you're going to be turning into me to show me that you understand how to make a linear flowchart. So the first thing we have to create would be, I was waiting for the class to respond. Anybody? There's no one in the room. Okay, we're going to start with the begin. So the first thing you have to create is the begin oval. Now from there, remember the first step in this direction, or in the directions, we can only use one of these three commands. So what's the first thing we have to do with this bus? It has to start moving, but we can only move one block at a time. So to get it here, that would be move forward. So you're going to write move forward, and you have to write it in camel case. That means all one word, but the second word that you start has to be capitalized. Okay? So if I look at our map here, we are now here on the map. So what's the next command we have to do? As you can tell, we need to do a move forward. No, you can't write move forward 3, 4, 5 times. You actually have to write the words move forward every time, because remember, if this is a robot or a computer in the GPS sense, it can't think for itself. It doesn't know exactly how far to go. But if we make a specific amount of distance can count as one forward. That's how we keep this moving. So now we are here. So what's the next command to get here? Another move forward. Okay, that puts our bus, go away. That puts our bus here. And we're going to have to do one more move forward to get it to this point. So if I move it there, we now have to make sure we put a fourth box on here. Move forward. Okay, seeing how this works? All right, now the next command, we have to get the bus to turn this way. And as we saw already, that means we have to turn the bus, and we turned it to the left. So our next command here, I'm going to go over to the side so I can keep using the same page. Turn left. Okay. And what's the next command going to be after that? You guessed it, move forward. So I'm going to go up now, move forward. Okay. And you're going to keep going until you get to the end. And the end is when the bus is sitting in the parking lot. Okay. It's not around it, it's right on top of it. That's going to be your final step. So you're going to have to submit for me. I'm going to have a Google form for you to fill out on Google Classroom in this 1.2, and you're also going to see this video on here as well. And you're going to have to submit your Google form. That's going to help me to understand that you know what you did. So you're either going to do a digital version of this and share that, or you're going to take a picture of this and share it with me. If you don't know how to take a picture and you don't know how to, or you don't know how to download a file or anything like that, then you're going to have to come see me during my office times, 9 to 11 in the morning or 1 to 2:30 in the afternoon. And you can either show it to me on the screen and I'll read it and I'll carefully look at it, or I can help you to tell you how to share a file. Okay? So besides that, you're also going to be completing this question. Actually, you know what? I'm going to skip that question. We're just going to skip it. All you're going to have to do is share the presentation with me, and that's it. So that's all we have for today's lesson. We will talk to you next time.